Hi, this is a little lesson on equivalent fractions. Now, in the last lesson, we were doing simplifying fractions, and to my mind, equivalent fractions is kind of the opposite of simplifying. So let's just have a look at an example. Okay, so in this diagram, the rectangle at the top shows two parts shaded in and three parts altogether. So therefore, the rectangle at the top represents 2 out of 3, which is, of course, 2/3. Now, in the rectangle at the bottom, if you notice, the rectangle is exactly the same width, exactly the same size from here to here. And what I've done is I've drawn a line down from where the thirds are, and then what I've done is I've split each of those boxes up into two. So that third has now got 2, this third has now got 2, and this third has now got 2. So if you remember, this is originally a third, this is also a third, and this is also a third. So each of those thirds is now broken up. So now what we've got is not thirds, but sixths, okay, because there are 6 parts. And all I need to do now to make the equivalent fraction is to shade in exactly the same amount. Now, because I'm doing it visually, you can tell that so far I've gone halfway, but I haven't gone far enough because this amount at the top is much more than this amount. So if I shade this box in as well, now we can see that the rectangle at the top has got the same amount of shaded as the rectangle at the bottom. But the rectangle at the bottom has got 1, 2, 3, 4 parts shaded in. So therefore, it's 4 out of 6. So it's 4/6. So what we're saying is that 2/3 is equivalent to 4/6. And that's all there is to it. So what we've just proved is that 2/3 equals 4/6. Now, with equivalent fractions, what you have to do is you have to multiply exactly the same number at the top and at the bottom. So if we multiply by 2, so we've got 2 multiplied by 2 is 4, and 3 times 2 equals 6. Okay, now with equivalent fractions you can just keep going on and on forever. So if I were to ask you what is equivalent to 4/6, then obviously one answer is 2/3. Well, yeah, but we've just done that. But let's multiply by, I don't know, let's multiply by 5. Remember, you must do the same thing, top and bottom. Draw the arrow in there. So 4 5s are 20. Okay, and then 6 5s are 30. So this tells us that 4/6 equals 20/30. But it also tells us that 2/3 is 20/30. Now, some of you will immediately see the connection and see that you've gone from 2 to 20, multiply by 10, and 3 to 30, multiply by 10. Some of you will also see another connection because you've seen multiply by 2 and then multiply by 5. And if you multiply by 2 and then by 5, then together that's the same as multiplying by 10. Now the thing about equivalent fractions is that you can multiply by just about any number you like, and sometimes it might seem a bit silly, but it still works. So for example, let's just pick a really awkward number like 13. Now 13 hardly ever gets used in maths because well, it's a prime number, which means it's only got two what they called factors, 1 and 13. So 1 goes into 13, 13 goes into 13, and nothing else. So it's a pretty rotten number, really. Some people absolutely love these numbers, by the way. So 3/14 is 3 times 13. Well, I can do that fairly easily because 3 times 13 is 39. And then 14 times 13, let's just do that by long multiplication. 3, right, so 3 times 14 is 42. And then 10 times 14 is 140. Okay, see that there? And then if we add them, if we add them together, that becomes a 2, 4, 4, 8, and a 1, 182. So 14 times 13 is 182. Now, I am prepared to bet that you will never ever have to tell anybody that 3/14 is 39 182ths. However, that's not the point. The point is you have used the techniques of equivalent fractions to work out and say that those are the same. One question you might get asked is, the question might look like that. So it might say 3/4 is how many eighths? So first step is you've got to find out what have they done to 4 to get to 8. And hopefully you can see fairly quickly that they've multiplied by 2. So therefore that tells you what you've got to do at the top. You've also got to multiply by 2. 3 times 2 is 6. Okay, so we can get rid of the question mark. So 3/4 is the same as 6/8. Now, if you don't believe me, again, best way to do, oh dear, what's going on here? Oh, that's not very good at all, is it? Start again. Right, circle first. There we go. Line, line. Right, 3/4. Now 3/4 is that shaded in, and that one shaded in, and that one shaded in, and this one not. Okay. Now you can. I'll explain in a moment why I'm not doing the squiggle. So 3/4 is the same as 6/8. Well, if you want eighths, all you have to do is take each quarter section and divide it into 2, like that. Okay, looks a bit like a Saxon shield now, but anyway. So now we've got this one, this one, this one, this one, this one, and this one. Remember, these two are not shaded. So now the amount that is shaded in is still the same as it was before. It's just that last time it was shaded in with 3/4, and this time it's shaded in with 6/8. And another way of proving it is to use the bar model, because they seem to be quite keen on that. So let's show you quarters here. Okay, so quarters is 3/4 like that, and then the equivalent, what we have to do is to make eighths. So best way is to chop it in half, and then each of those, chop those in half, half and half, and then there and there. So let's just check 1, 2, 3, 4, 5, 6, 7, 8. That's fine. Okay, and I now have to, I'm saying that it's the same as 6/8. So let's just prove it. 1, 2, 3, 4, 5, 6. And now you can see, hopefully you can see that this amount shaded in is about the same as this amount shaded in. So therefore that's equivalent fractions. Okay, boys and girls, that's the end of my input. So now go back to the website and follow the instructions for the next part of the lesson.